Hey everybody, this is a quick intro into the xDateR Shiny app that I've made to help users cross-date ring width data or density data or anything using existing functions in DPLR, but to provide a graphical user interface and interactive format to do that, which is a little more intuitive. You don't have to script everything at the command line. So we're over here at andybun.shinyapps.io/xDateR. You can also get all the source code for this on GitHub, and you can run it locally on your machine if you don't want to run it here in a web browser. But you certainly can run it on a web browser. You can read this sort of blurb here on how the app generally works. But if you're like me, you probably just want to jump in and start using it. The only thing I'll do is to beg you to cite these two papers if you publish any data, if you publish anything having used DPLR. It helps me get a little bit of credit for spending a lot of time developing open source software tools. So here's the jumping off point. This is where you upload a ring width file. This uses the read.rwl function in DPLR. At any point, if you see any functions sort of outlined here in red, you can get the help file for those functions by clicking on them. You can upload a file here by browsing or dragging a text file in there, an RWL file, a compact file, etc. I'm going to show you how you can play around with this using example data, where I've taken a ring width file and I've corrupted some of the dating in the series randomly in order to sort of screw around and learn how to use the functions in xDateR. So once we upload a file or click the example data box, you can see some new tabs have appeared. So for instance, the first thing you might want to do here is to describe the data. And so if you click on that, you can see the file you've uploaded. You can see the dates. You can see where each series is. So you can see here, ABC 106 runs here at the end of the chronology, and each one here is presented unto itself. You can look at it as segments. You can look at it in what we call a spaghetti plot, and then you can get some summary statistics on each series. This is sort of on the whole ring width file, and this is sort of on each series. And again, you can look at the help file for any of these if you click on that underlined hyperlink there. And you can look at the help file. This is the help file for DPLR, and you can read a little bit about it. Okay, the other thing before we get going, I guess, is that on all these pages here, you can generate a report. And generating the report here will create a standalone RWL file, HTML file using R Markdown, where everything that happened on that page is then spit out into a static HTML file that you can go back and look at later. The bottom of each of these pages has the R code that you need to make this reproducible. One of the main reasons we like using open source software and working in R, the main reason I like it is that everything can be reproducible. Okay, let's go back here to the app. We just described some of the RWL data. Let's look at the workhorse function for xDateR. This is the correlations between series tab. What this shows is output from the core.rwl.seg function in DPLR, and what this does is looks at the correlations for a whole RWL file by overlapping segments. A lot of the terminology will be familiar to Cofacci users here. And before I jump in and explain, just as you scroll down, you can look. There's a lot of options you can mess with dynamically. So you can change sort of the segment lengths. You can change whether the series are pre-whitened or not when you start working with them, and everything sort of updates on the fly. You can remove problematic series or a series you don't want by unchecking these boxes. You can update it, and then those series are dropped from the analysis. I'll use the full suite for right now. I'll let you go through and read about most of these options. Probably the one you'll mess with most is the segment length, and then also the bin floor. So what this shows is correlations for overlapping segments. At the moment, these are really long segments with this at 100 years. So these are 100-year segments overlapped by 50 years. You can change this to change the years at which those segments will start. So if we change the bin floor to 50, then the segments will start, the first segment that would then start at 1250 way back here to 1350 would be the first one, 1350 to 1450, and so on. This is a graphical output that lets you look at the overall dating at a glance. So this is using these very long segments. We can see here that of all the series that exist here, segments that are colored blue are ones that correlate well with the master chronology, and ones that correlate less well are colored in red. Segments that don't completely overlap the master chronology are shown in green. You can change the critical value, you can change the correlation coefficient method, etc., using some of these options. So let's scroll down a little bit. This graphical output from up here is also shown down in the tables. This shows sort of the overall series correlation, how well each series correlates to the master chronology. And just like in Cophacia, the master chronology is built with from all the other series except for the one you're looking at. So the master chronology here for ABC 101 is every other series makes up the master chronology, except for 101's been withheld, and then 101 is compared against the master chronology. So this shows you the overall correlation for the series. This shows you the overall correlation for the bin, for each bin. And this shows if there's any flagged series or series and segments. So this shows here that series 104 and 118 have some issues with the dating potentially. And those are the ones that are colored red here. If you scroll even further down, you get to see each segment for each series. And the correlations are shown, they're bolded if they correlate well, and they're not bolded if they don't correlate well. So going down here to series 118, we can see that it correlates well from here, from the 1800 to 1900 bin. But as you move back in time, it stops correlating well and actually becomes sort of weakly negatively correlated at 1700 to 1800. And as before, you can generate a report, and you can, of course, change any of these arguments at any point. The next thing you might want to do is look at the individual series correlations. So we see now at this point that series 118 and series 104 have some kind of dating, or some kind of problem with the correlation. Could be a dating problem. It could just be a weakly correlated series. That's always up to the user to determine. This tool can help you identify statistical problems. It can never actually look at the wood for you. So here we can look at the correlation and the cross correlation between a series and a master chronology in a little more depth. Here are the functions, the TBLR functions that are shown on this page. Correlation of a series by segment, cross correlation of a series against a RWL file, and so on. So you can read through this and jump in and look. So what this plot shows is here for series 101, the correlation for each segment, as we saw on the previous page, as well as a running correlation that is equivalent. The running correlation is a centered window around whatever your segment length is. 101 dates pretty well. Let's go down and look at 118, was one of our problem children. So let's go here and look at 118. And so if you look at series 118 on here, you can see that this correlates well for the first part of the record, or the last part of the record, the most recent period, and then the correlation sort of falls apart. It starts falling apart right here in this sort of and this is the 1785 to 1835 bin, and by the time we get back here, the correlations are not significant. They fall sort of down towards zero. And as before, we can change this correlation length. This particular data set is really exquisitely well dated and allows you to look at relatively short segment lengths and still have some confidence in what you're doing. So again, back here, by the time we get to 1795 to 1825, it's pretty well correlated. Down here, 1780 to 1810, it's starting to fall apart. It's falling apart. Okay, so we want to look at it up closer. We can look at cross correlations, and this is just Cophacia outputs this as a text file. This sort of lets you look at it graphically. So this looks at the cross correlations for each segment. looking forward and backward, in this case 5 years, looks forward 5 years and backwards 5 years, and correlates each segment by shifting that segment in time and looking at the correlation coefficient. And so the overall pattern here is that it correlates at lag 0 really well as you move back in time until you get down here to, here the 1785 to 1814 bin starts falling apart. And by the time you get down here to 1770 to 1799 bin, we actually have a strong correlation again. It's just at a lag of -1. And negative lags in here are indicative of a missing ring in the series. So we have a suggestion at this point that we're missing a measurement in this particular series. We can zoom in if we want to look at this in some more, look at it a little closer. So here we're just going to look in, we're going to zoom in on these bins here. And again, 1800, still well correlated. By the time we get back into 1790 to 1819, the correlation's getting weaker. By the time we get back into this window, it's suggesting a -1, and then it's a strong -1 moving backwards in time. So we wanted to, what I do at this point is I actually sort of start playing around with this function and trying to figure out exactly where the correlation starts falling apart. So here, we're well correlated. 1800 to 1829 is well correlated. It's weak in this window and is a strong -1 by this point. So I'm looking at this series and I'm really thinking that we have a dating problem somewhere in the 1785 to 1815 range here. And that corresponds pretty well to what we're seeing back up here. Starting to fall apart here at this window. Another tool is this cross correlation along with a skeleton plot. This is a tool that sort of takes some time to wrap your head around a little bit. What you can do here is you can center a window. So we could center a window here around the year 1800. And what this will do, if our window width is 100 years, we will look at 2 periods in time centered on the year 1800. So here, back on the left here, we're looking at the period 1750. The whole thing is looking at the period 1750 to 1850. The left portion is 1750 to 1799. The right portion is 1800 to 1849. This shows you the relative correlation at these various lags, and this shows you a skeleton plot of potential marker years. So here we can see, like for instance, our 1808 marker year is represented both in the series and in the master. When we jump over onto this side, we can see that everything's sort of offset by 1. Our markers here, our skeleton lines are sort of offset by 1. And this, if you were visually cross-dating using graph paper, you would have come to a sort of similar conclusion onto here. So we can see, for instance, using this window here, the correlation at lag 0 is 0.5, which is not terrible, but the correlation from 1800 to 1850 is 0.9, while the correlation from 1750 to 1800 is down -0.174. So at this point, I'd be looking at this series and really feeling like there was a missing ring somewhere around the year 1800. And so if I was trying to date this series, I'd probably take some notes at this point. And I would enter these notes here and say, investigate the core for a missing ring in or around the year 1800. So I could save this as a report. And if I did that, click on that, the report is then generated. If I want to, I can look at it. Here's our series correlation report. This is a standalone R Markdown document with all the information we need to repeat that later. So we have all that same information, all the parameters we're using for the various functions, all the graphical output that we've used, and then the reproducible R code to look at that again later. And I'll let you spend some time fussing around with that. Let's imagine this point that we were confident that it was the year 1800 where we needed, where there was a missing ring that we didn't know about. We might have, hopefully at this point, we've gone and looked at the wood and sort of agreed that that's where it was. If you can play around with adding and and deleting rings under the Edit Series tab. And so here we've got series 118, and if we think there's a missing ring around the year 1800 or in the year 1800, we can actually edit the RWL file right here using the insert ring and delete rings functions. And so to do that, we could go here to find the year 1800 by sort of scrolling through, finding the right page. And so here we've got the measurements over here. These are actually the ring width measurements in millimeters and for each individual year. And so we thought at this point there's a missing ring around the year 1800. We can highlight that and actually insert a measurement. So we can insert a measurement by clicking here, inserting a 0 there. So if we go ahead and do that, we've inserted that measurement. There's a log that's written so that we'll know what we did. So if we generate a report, we'll know exactly what we did along that way. And we can go and actually see if it's there. So we inserted a 0 in the year 1800. Let's see if it's here. So we inserted it actually here in 1799 because it added it. We highlighted 1800 and it inserted it the year before. That may or may not be right. I wouldn't, at this point, say the RWL file was good to go, upload to the RTIRDB or whatever. What I would do at this point is actually go back and look at my correlation plots and see if that fixed the problem. And so if I go back here to look at series 118, after we added that ring, we're all blue. So we're correlating well at that point. We can go in here and look at here's series 118, and we can see it correlates well throughout, at least moderately well. There might be some issues in there still that we'd have to investigate more, but that's definitely a start. If the point is that you actually go into the wood and found that it was the year 1799 that was missing, in that case, you could download the RWL object in a Tucson format. So if you actually click on that, we'll download the RWL file, and we have the actual text file that you can use later. If you don't like the changes, if you feel like you did something wrong, you can revert them. Go back, see our log says we've reverted. The log's been reset, and if we look now back at series 118, we'll find we're back to the same problem again. So that's kind of an introduction to how these functions work in the XDateR app and in DPLR. I'd encourage you at this point to now go down and look at, play along at home, and try and do the same thing with series 104 and sort of find out maybe what's wrong with series 104 down there and see if you can figure out what's happening. I'll make another video later that lets you look at how you can work with undated series, so how you can try and cross-date a floater, one that you don't have information on, and see how you can slide it into a master chronology and make a stab at finding out what dates those are. So happy cross-dating, everybody. Have fun playing with it. Let me know if you have any suggestions for how to improve it. We're definitely still in the development phase on this app. I sort of threw it together over the summer when I should have been doing other things, but I kind of got a bug to work on it, and hope people find it useful. Please cite it if you use, please cite DPLR if you use this, and more importantly than citing it, remember, never rely on statistical cross-dating alone. Statistics are great, but they never are a substitute for going and looking at the wood. So figure out what's happening statistically, but always go get yourself a good microscope, look at the wood carefully. Hope that helps, and happy cross-dating and happy R-ing to you all.